Well, hello, this is Mr. Wilczewski again. This is the Advanced Chemical Reactions lesson, Section 2, Balancing Equations. We're going to do this one a little bit differently so you can see what I'm doing in real time. So, I have an equation here, H2 plus O2 yields H2O. So, let's see what's happening here. Let's use this circle to represent a hydrogen atom. And we'll represent the hydrogen molecule H2 with two circles. Now we'll represent the oxygen atom with this larger and red circle, and the oxygen atom that's bonded to it as a larger red circle. So in this reaction, if you could shrink yourself down to the size of atoms and watch what's happening, you would see one of these hydrogens break loose and attach itself to one of the oxygens. Then the other hydrogen here would also break loose and attach itself to that same oxygen. So you'd make a water molecule like this. H2O. Now, I have a question for you. What happens with this other oxygen? Think about that for a minute. You can pause the tape if you need more time. When you're ready, turn the tape back on and I'll give you the answer. Well, what happens is you don't have just one hydrogen molecule, you have billions of them. So a second hydrogen molecule would break apart and attach itself to the other oxygen, likewise with its sister oxygen, and then you'd form not one, but two water molecules, like this. So now you have a balanced equation. And the way to represent that, let's go back up to the original equation. Here we had one hydrogen molecule. Well, it takes two to make this equal. Because let's count them. Here you have one hydrogen atom, two hydrogen atoms, four hydrogen atoms. And over here you have 1, 2, 3, 4 hydrogen atoms. That's a balanced chemical equation when the number and kind of atoms are the same on both sides. And let's count the oxygens. You have one oxygen, two oxygen, one oxygen, two oxygens. Now the way to represent this in the balanced equation is to use numbers called coefficients. So I'm going to put a coefficient here in front of this hydrogen. Since there are two hydrogen molecules, we're going to put a 2 there. Now there's only one oxygen molecule, so 1 suffices. And when you see nothing, that's understood to be 1. And over here on the product side, we have two water molecules, so we're going to represent a 2 here. These numbers I drew, this 2 and this 2, they are called coefficients, and they're used to balance chemical equations. Now this is a fine method for working, but if you get more complicated molecules, it's going to be very difficult to make all those drawings. So I'm going to show you how an almost foolproof method for balancing chemical equations. So, what you do is you have your unbalanced equation here, and then you draw a line in front of the equation. Then you make rows. You make a row for each element or polyatomic ion. So we're going to make a row for hydrogen here. Then we're going to make another row for oxygen. No, it should just be an H, not an H2. You're just keeping track of individual atoms. Then we draw a line right down the middle, right underneath the arrow. So now the next thing you do is you take inventory after you make your chart. You have hydrogen atoms, we have 2 here, H2. So you put the number 2. Over here in the H2O, you also have 2 hydrogen atoms. So that's cool, that works out well. Oxygen here, you have 2 oxygens. So you put a 2 there. And over here you only have 1 oxygen. So there's the problem. You only have 1 oxygen on that side. So you need to make it all these numbers well, not all the numbers, but you need to make the hydrogens equal on both sides and the oxygens equal on both sides. So, and the only thing you can do is change the coefficients. So I'm going to write in here in red the coefficients that are there at the moment. That's 1, 1, 1. Remember, if there's nothing there, it's assumed to be 1. So in order to make this 2 oxygens, you should change that 1 to a 2. Now you have 2 water molecules, which each one of them has an oxygen, so you have 2 oxygens. So we can change this to a 2. All right, but we're not done yet, because what happened to the hydrogens? If you had 2 water molecules, you now have 4 hydrogens. So that means you don't have enough hydrogens over here. So you have 2, but you want to make it 4, so you would do that by changing this coefficient to a 2, and then that would give you 4. Then you should always double check. You have 4 hydrogens here and 4 here, 2 oxygens here and 2 oxygens here. So let's rewrite this equation just so it's neat. So the balanced equations is 2H2 plus O2 yields 2H2O. There you go. That's the balanced chemical equation. Now let's practice this. Here we have magnesium and oxygen reacting to make magnesium oxide. We'll make our chart like this with the magnesium on one row, and we'll put the oxygen on another row, and we take inventory. Magnesiums, we have 1 magnesium. Oh, don't forget the middle line here. For magnesium on this side, there's only 1. The oxygen, we have 2 oxygens over here, but over here we only have the 1 oxygen. So this is what we have to fix. So we will, there's understood to be a 1 here, we'll make it a 2. That becomes a 2, then you have your 2 oxygens. But that also messes with your magnesium, now you have 2 magnesiums. So how would you fix that over here? I'm going to pause for a minute while you think about that. Pause the tape if you need more time. Okay, if you answered put a coefficient here of 2 in front of that magnesium, then you're correct. Now we have 2 magnesiums on this side, and 2 on this side, and 2 and 2 oxygens. Here's what I want you to try for practice. You have carbon plus oxygen gives you carbon dioxide. So pause the tape right now and try this on your own. And when you're ready, start the tape again. Alright, here we go. We're going to make our chart. We'll make a row for the carbon. Make another row for the oxygen. Take our inventory. We have 1 carbon here and 1 carbon over here. We have 2 oxygens here and 2 oxygens here. You're done. Right, this one was already balanced. Alright, now at this point I usually give a quiz in class, so I'll make this a self-quiz. So take this reaction, sodium and chlorine, and balance it. I'll pause the tape now if you need more time. Start it up when you're ready. Okay, let's make our chart. We have sodium on one row, chlorine on the next. We have 1 sodium right here. We have 1 sodium here. Chlorines, we have 2 chlorines, but only 1 over here. So in order to fix this, you would put a coefficient here that makes 2 sodium chloride. So that fixes the chlorine to 2. It also changes your sodium. So to fix this, we need to put another coefficient over here in front of the sodium. So we have 2 sodium. So let's rewrite this answer so it's neat. We have 2 sodiums and 1 diatomic chlorine yields 2 sodium chloride. All right, let's try another one. Here we have iron sulfate, Fe2SO4, parentheses 3. So there's 3 of these sulfate polyatomic ions and 2 of the iron. And we have aluminum, and that makes aluminum sulfate, Al2, parentheses SO4, parentheses 3, plus iron. All right, so pause this tape, try this on your own, and when you're ready to see the answer, turn it back on. All right, here we go. Let's set up our chart. Now this one is different from the others because it has some polyatomic ions in it. Now we make a row for iron. The SO4 is the polyatomic ion known as sulfate. It stays together. It's the same on both sides of the reaction. So what you can do with that, you can save yourself a lot of work, and you can make one row for that whole combination, SO4. And also let's make a row for the aluminum. Okay, your next step is to take your inventory. So you have 2 irons here, 1 over here. You have 3 sulfates over here, and you have 3 sulfates over here. That's cool. Aluminum, you have 1 aluminum here and 2 aluminums here. All right, so let's take a look at this. The first thing I'm going to work on is the aluminum. That's pretty easy. We have 1 over here, but we need 2. So I'm going to put a coefficient of 2 right there. That changes that to 2. Now the iron is next. We have 2 irons on this side and 1 on this side. So if we put a 2 here, that'll fix that. And let's double check. We have 2 irons here and 2 over here. We have 3 sulfates here and 3 over here. And aluminum, we have 2 and 2. All right, so we're good. So this is the final answer. All right, let's do one that's a little bit harder here. This is the kind of one I want you to expect on your quizzes and tests. We have iron oxide, Fe3O4, and aluminum yields aluminum oxide and iron. All right, so pause the tape now if you want to try this on your own. It may take you a while. This one's a little more complicated. When you're ready, start the tape back up again. Okay, let's give this a shot and set up our table. We have iron on one line, oxygen on the next, and then aluminum. So let's begin by taking our inventory. We have 3 irons here and only 1 over there. Oxygen, we have 4 oxygens here and 3 over here. Aluminum, we have 1 aluminum here and 2 here. Alright, so let's just start with the iron. We have 3 over here and 1 over here. So let's make this a 3. And that'll take care of that. Now, let's take a look at the aluminums. We have 1 aluminum here and 2 here. So I just make that a 2. That'll fix that. Now, the oxygen's going to get a little trickier here. Now, remember, if there's no coefficient there, it's assumed to be 1. So I recommend, until you get really good at this, that you change your coefficients by 1, upping 1 each time. When you get better at this, if you can see the answer, you can skip over them. But the pitfall of skipping over them is that you might skip over the right answer, and then you'll be here for many, many hours trying to balance it up with huge numbers. All right, so let's take a look at this oxygen. We have 4 over here and 3 over here. So you know we need more over here. There's an understood 1 for a coefficient. So let's just make it a 2. You know that's not going to fix it. right out, but let's just do it one step at a time. So we make that a 2. That means you have 2 Al2O3s. So that multiplies these oxygens by 2. So instead of 3 oxygens, you now have 6 oxygens. And aluminums, you have 2 Al2s, so that means you have 4 aluminums. Alright, so we can fix the aluminum pretty quickly just by making that 2 a 4. Now, getting back to the oxygens, if we have 6 over here and 4 over here, then we need more on the reactant side. So there's an understood 1 there, so let's make it a 2 right there. So now that means we have 6 irons, and 2 times O4, we have 8 oxygens. So to fix the irons, we have 6 here. That's pretty easy. Just change that 3 to a 6. Now we have 6 irons on both sides. Alright, let's go back to the oxygen. We need more oxygens on this side. So let's just change that 2 to a 3. So now we have 6 aluminums. And 3 times O2, we have 9 oxygens. So to fix the aluminums, we can just change this to a 6. And that'll fix our aluminums. And the oxygens, we have 9 here. We don't have enough over here, so let's make this a 3. That gives us 9 irons, which we can fix over here by making that a 9. And that gives us 3 times 4, that gives us 12 oxygens. Alright, so in order to get 12 oxygens over here, we would change that to a 4. Then we have 12 oxygens. And our aluminums, let's see, we have 6. We didn't change that. We have 6 aluminums here and 6 here. Okay, so this should work. So the correct answer, let's rewrite this, is 3 Fe3O4 plus, oh, hold on, no, we're not done yet, because look at these aluminums here. Look at these. We have 4 times 2, that we forgot to change, I forgot to change that to an 8. So we have 8 of these. So now we have to have 8 of these. Alright, so the answer is 3 Fe3O4, 8 aluminums. Always double check. Alright, I forgot to double check, but that's why we double check. Alright, there we go. 3 FeO4 plus 8 aluminums gives you 4 Al2O3 aluminum oxides and iron. Alright, let's take a look at this. Here we have we have a list of equations here. Tell me which ones are balanced. I'm going to pause this for a minute and see if you could tell me which ones are balanced. Well, start the tape back up when you're ready. So yes, this is balanced, this is balanced, this is balanced, this last one is not balanced, however.